Hello, my name is Nathan Farragut and my client is Ryan Goldberg. And the purpose of this site, Quick Stats, is to help people learn the basics of statistics with useful tools that are built within this website. So far, people can go to the graphing page and learn about graphing or plotting data onto a histogram, and they can learn about z-tables and z-scores, and they can go on the distributions page to learn about binomial distributions and their purpose in the world of statistics. Now, the purpose of this graphing page is to graph a histogram, and as you can see in these images, they're received by an AJAX request and displayed. They show different distributions of histograms. And the main functionality of this page is to enter data and submit it to see a histogram generated of that data. So if I enter data here separated by commas, let's say I add a bunch of 2's and then like 7 and 8. As you can see, the 2's occur 4 times and the other ones occur once. Below the graph, the mean of the data is evaluated, as well as the standard deviation. Also, users can enter in their own data in a CSV file and submit it, and the mean and standard deviation are also calculated, and the data is displayed on a histogram. Now this histogram mainly looks roughly symmetric and unimodal, but there's a little bit of a skew. So that's pretty much it for the graphing page. Now the z-table page, of course, displays a positive z-table and a negative z-table. And this description here at the top of the page roughly describes why we want to use the z-table. So to use a z-table, first we want to enter the standard deviation, raw score, and mean. So just for this example, I'll just put in numbers. Say the standard deviation is like 8, the raw score is 5, and the mean is 10. Now, upon clicking Find Z-score, the Z-score will be either positive or negative. In this case, it is negative. It is negative 0.625. Now, negative 0.6, it's roughly 0.63, so that's 0.2676, and that will be the value at which the probability of z will be less than negative 0.625 will be roughly that value of 0.26. And that means that for a raw score of 5 or lower, there'll be roughly that 26% chance of that value being randomly selected. So this is it for this z-table page. Now for the distributions, there are the binomial distributions. So this is, as mentioned above, it is to find the probability of success given a number of trials, number of successes, and the probability of success. So theoretically, let's say we're flipping a coin. So the probability of success would be 1/2. Let's say like flipping heads would be 0.5, and that would be a success. And we flip the coin 3 times, and let's say we get the coin landing on heads each time, so there'd be 3 successes. And that shows there is a 0.125 chance of that happening, which is roughly 13%. So another thing, if we leave the number of successes empty and submit, a table is generated showing the probability of 0 successes, where if they all land on tails, it would be 0.125. And if there's 1 success, the probability would be 0.375, and so on and so forth for 2 and 3. So that is the overall, all of the functionalities of these pages, and each of these pages do represent the requirements that were given to me by my client, and I believe that they meet the expectations. Alright, thank you for watching. That is what my website.